about a distribution for the sample proportion. So here's the scenario. If I wanted to determine the number of households in Monroe City that would favor a tax increase to fund a new baseball field. Okay, we know the best way to do it would be to ask everybody, are you in favor of this or not? That's really not feasible. It's time consuming. It costs a lot of money to do that. So we know that we could find like a sample and essentially just say, are you in favor, yes or no, and get their value. So that is a proportion. I'm not taking every possible sample of people in Monroe City. That's way too time consuming. But I could get one particular sample and get the proportion that was in favor. So when I'm talking about a sample proportion, we denote that as P hat, and it's just X over N, the number of people that said they're in favor divided by the number of people that we asked. So for instance, in a poll, 1,745 registered voters were asked if they approved of the way George W. Bush was handling the economy. 349 said yes. I want a point estimate. So when I see point estimate, that tells me I'm looking for that P hat for the proportion of registered voters who approved. So the proportion that said yes. So P hat is X over N. X is what? 345, 9 over N. Okay, and so then if I divide that, we get 0.2. So my point estimate is 0.2. That means I could estimate 20% of the population was in favor based off my sample. Any questions about that part, just finding a P hat? That formula is not on our formula sheet, but I think we can remember how to do that one. Just divide them. So a few things when I'm talking about the distribution for these. So yesterday we were looking at distribution of a sample mean. I took a sample and I found the mean. Here I'm looking at a proportion, just X over N. As N gets bigger, it will become more normal, just like we saw with the ones yesterday. Yesterday, how big did it have to be normal? 30 or bigger. It was automatically going to look normal. The center, as it appears more normal, we know that in a normal curve, the mean is the center. So that will be our population proportion, our P. Spread, basically, as my sample gets bigger, I should have more consistent data, so my standard deviation will get smaller. All the things that we've seen before. Bigger sample, smaller standard deviation, looks more normal. What we really need to know, and this is on your formula sheet. The first part, I said it's all on there. This one is not. This is the criteria we have to check to see if our sample is big enough. With the X bars, we just had to say bigger than 30 was big enough. With these, it has to be true that N times P times 1 minus P is greater than or equal to 10. And technically, it should also be true that my sample is less than 5% of the total population. Just for independence reasons. So these are the two things. Before I do any of these problems, I'm going to check my criteria. Those are the two things you need to check. So note those. That's not on the formula sheet. But the mean and standard deviation are. So the mean is just our proportion for the whole sample. Standard deviation is P, the square root of P times 1 minus P over N. So now we're just going to do a few examples with this. This is what I'd already said, that it had to be more than 5%. So Okay, according to a poll, 42% of registered voters believe the president should be impeached. Suppose that we obtain a simple random sample of 50 voters and determine which voters believe the president should be impeached. Determine the sampling distribution of the sample proportion. Okay, when I see sample proportion, that means I am talking about p hat. This 42%, that is the proportion for the whole population. So that's just regular p for the entire population. What's my n on this problem? 50. Okay, it did not say anywhere that it was normal, so we need to check. So my criteria. Okay, n times p times 1 minus p has to be greater than or equal to 10. So 50 times 0.42 times 1 minus 0.42. And we get 12.18 for that, so it's bigger than 10, so we're good. Second, 50 voters. Would that be less than 5% of the whole adult population in the U.S.? Mm-hmm. Yeah, a lot of times there's not an actual calculation here. But 50 is definitely less than 5% of our whole population, so we're okay. We can assume independence. So when I check these criteria, that means it will be close enough to normal that we can do the normal stuff. On these, I expect to see something that you check the criteria. I don't need a lot. So if you just put, this line, the 50 times 0.42 times 1 minus 0.42, and that n is less than 5% of the total population, that's good enough for me. I just want to know that you're thinking about it before you go into your problem. So now, if we're going to calculate things, we need the mean and standard deviation for sample proportion means p hat. And I did try to give you guys a blank slide after this, so if you need more room, there's a blank slide following it on your notes handout. All right, so the mean is just the proportion from the population that we were looking at, which is 0.42. Sigma, the square root of p times 1 minus p over n just like yesterday, let's keep a few decimal places on this so we don't have a lot of error. Okay, I was just asking you to describe the sampling distribution, so this is what I'm looking for. When I ask you to describe the sampling distribution, that means check the criteria, give me the mean and standard deviation. So I didn't ask you to actually calculate any probabilities here. Any questions on that? So let's actually do some probabilities. So according to the Centers for Disease Control and Prevention, 18.8% of school-aged children aged 6 to 11 years were overweight in 2004. What is this 18.8? That's our P, the proportion from our population, 0.188. So part A, in a random sample of 90 children. So the 90 is my N. What's the probability that at least 19% are overweight? Before I can do anything, I need to know if this is normal. So the first thing I'm always going to do is check my criteria. We have to check N, which is 90, times P, 0.188, times 1 minus P. So that gives me 13.74. What do I need to be true about that? Right, it has to be greater than or equal to 10. It is, so that condition is met. Second condition, my sample has to be less than 5% of the total population. Would 90 children be less than 5% of the entire U.S. school-age children? Yeah, so we're good there. All right, let's go ahead and find our mean and standard deviation. So we're talking about our population proportion. So my mean is just that p-value that we were given in the problem, so 0.188. Standard deviation is the square root of p times 1 minus p over n get 0.0412. So now we can actually do part A. So everything I did was just describe my sampling distribution. Check your criteria, mean, standard deviation. I want the probability, 19%. Anytime you're talking about percents, that's your proportion. So my p hat, at least means greater than or equal to 0.19. What do I have to do? Find the z, just like yesterday. So z is our value minus the mean divided by standard deviation. How do we find greater than? Okay, so go to our table. If we look up 0.05, minus that, we get 0.48. So really what we have to do on these problems, you have to be able to look at the problem and know, am I talking about the sample means or am I talking about a proportion? A lot of times I might say sample means or sample proportion. So I might tell you, if you see a percent in the problem, I'm talking about the proportions. So then you just need your mean and standard deviation for the p's, and you do the same thing as before. All right, so part B. Suppose that my sample results in 24 overweight children. What might you conclude? Okay, so if I'm talking about the p's, I have to have a proportion. 24 is not a proportion. What should I do with that? Yep, we need that point estimate. So 24 divided by 90 because there were 90 children. and we get 0.2667. I don't want to round that too much. All right, so I want to figure out, what am I concluding? Is this weird or not? Okay, we know that the table gives us the probability that it's less than. Is this higher or lower than we would expect? My mean is 0.188, so this is higher. Okay, here's my mean. We're all the way up here. If I find the probability that I'm less than that, is that going to tell me anything? No, because I expect you to be less than that. So to figure out if this is weird or not, let's find the probability that it is bigger than this. So we have to get our z. So our value minus the mean divided by standard deviation. So I need a probability that my z is bigger than 1.91. So greater than is 1 minus. If we look up 1.91, I get 0.0281. So what are we concluding? This is unusual. We would expect 5% or higher. So this is unusual. What do we conclude? Maybe our sample is different. Maybe the proportion has changed. Something does not add up. So something along those lines. Sample may be different. Or the proportion has changed. Most likely we have a poor sample in some way. There's something about our sample that caused it to be different than our original population. Is that okay? So last one. According to the National Center for Health Statistics, 15% of all Americans have hearing trouble. When I see a percent is a proportion. So I just gave you the p-value. So that tells me I'm talking about p hat here. I have to have the mean for p hat, the standard deviation for p hat. Part A, in a random sample of 120 Americans, what's the probability that at most 12% have hearing trouble? So my N is 120. Before I can assume this is normal, I have to check the criteria. So N times P times 1 minus P has to be bigger than 10. I get 15.3, so that's fine.
So what if it doesn't?
Then we can't do it.
I was like, we just can't do it.
Yeah,
Say,
we don't know. You could just say it's not normal, so we don't know yet how we would approach something like that. Second condition has to be less than 5% of the population. If I'm talking about all Americans, would 120 be less than 5% of the whole population? Yeah. So our criteria is good. My mean would be what? Standard deviation, square root of p times 1 minus p over n. So if I want the probability that at most would be less than or equal to, 12% would be 0.12. So I need the probability that p hat is less than or equal to 0.12. So we have to get our z. We're finding less than, that's what our table gives us, so we just look up negative 0.92 on the table. And we get 0.1788. All right, B, I said in my sample of 120, when I'm looking at people who listen to music using headphones, I have 26 with hearing trouble. What might we conclude? So what do I need to do?
Find the proportion.
Yeah, everything I'm looking at on this one is proportion, so we need the proportion. So 26 out of 120. That's higher than my regular average, so to figure out if this is unusual or not, let's find the probability that we are bigger than that number. So if we get our z, I do want to stress, make sure you're showing me work here. If you had rounded this p to 3 decimal places instead, you would have gotten 2.06 for your z. So there is a little gray area here. I just have to know how you're getting your numbers. So make sure you're showing me what numbers you're working with. So if you're off just slightly, I'll know that it was just due to rounding. All right, so we need the probability that z is bigger than 2.05. So greater than is 1 minus 2.05. I get 0.0202. So what's that mean? That's unusual. This group, we're looking at hearing loss, and we looked at a group that of people who listen to music using headphones. So what might we conclude?
Headphones cause you.
Yeah, people who listen with headphones have more hearing loss. They are different than the population in general. All right. Questions? So it's all very similar. You need to check your criteria when you're talking about X bar. Either I have to tell you it's normal or it has to be 30 or bigger. If we're talking about the proportions, has n times p times 1 minus p has to be bigger than 10, less than 5% of the population. Then you calculate your mean standard deviation, and we're doing our z's.